Hi, I hope everyone's doing well. Today we're going to start going over exponential growth and decay word problems. So turn to page 20 so we can get started on a few notes. In this unit, we've already learned the equation for exponential functions is y equals ab to the x power, where a is the y-intercept and b is the base. To determine if the equation is a growth or a decay, we need to take a closer look at the growth factor, which is also referred to as b. Now, the formula we're going to be using for all of the word problems are y equals a 1 plus or minus r to the t power, where y is the final amount, a is the original amount. The word you're going to be seeing a lot is going to be the word initial amount as well, which is the same as the original amount. The r is referred to as the rate, and the t would be the time. Now, very important with the rate of growth, it's going to be given to you as a percentage, and you need to be changing it into a decimal before you substitute it into the formula. So to convert a percentage to a decimal, you need to remember to move the decimal 2 places to the left. And I'll be showing you that when we get into a few of the examples. Now, for the annual growth, that's when you're going to be using the formula y equals a parentheses 1 plus r to the t power. So when there is a growth, it means that it's going to be increasing. And other words to be aware of would be if it says the word increase, growth, appreciates, gains, interest, or grows, that means to use the formula 1 plus r inside of your parenthesis. When it's going to be an annual decay, meaning that the quantity is decreasing, you will use the formula y equals a parentheses 1 minus r to the t power. If you see words such as decay, loss, reduce, depreciate, withdraw, or decrease, that's how you're going to know to use the formula with 1 minus r inside of the parenthesis. Now, when you're looking at the formula here, keep in mind that these letters can change, and instead of using a Y, they may use a V for value or a P. They can use any letters they want within the formula, so keep in mind the letters of themselves can change, and the formula is still representing the same thing. Now, on the bottom of this page, it says to first give the starting or the initial value, which is going to be the A value. So if you look at the example, the A is going to be the number in front of the parenthesis. So your A value or initial value would be 1,750. For B, my initial value would then be 79 in that example. Next, they're looking for the growth factor, which is B. Now, your growth factor is going to be the number inside the parenthesis is going to be your growth factor. So inside of your parenthesis would be 1.65 for your growth factor, and your growth factor for B would be 0.85. Now, to get the growth rate R, this one you do need to be a little bit careful with. If you look at example A on the bottom, it's saying that your growth rate is 65%. Now, what you need to do to get your growth rate is first you need to determine whether or not it is a growth or a decay. If your growth factor is greater than 1, then that means that this is going to be a growth. So you know that it's a growth anytime your B value is greater than 1. It's going to be a growth, meaning you would use the formula 1 plus r. So if you use the formula 1 plus r, that's how you got your growth factor of 1.65. So to solve for r, you would minus 1 from both sides, and r turned out to be 0.65. And to change it back to a percentage, go 2 to the right, which is how you would get 65%. Now, an easier way to figure out the actual rate is to always just take and subtract 1. So if you just do 1.65 minus 1, you get 0.65, which is going to be 65%. Now for B, your growth factor is less than 1. Since that's less than 1, you realize that this would be a decay. So if your B value is less than 1, you know that it's a decay and that you use the formula 1 minus R. Now you can take and set up 1 minus R equals 0.85 and solve for R to get your decay rate, or an easier way to do this would just take and do 1 minus 0.85, and when you subtract it, you get 0.15, go 2 to the right to get 15%. So for your growth rate, if it was increasing, you would just have to look at the number after the 1. If it's a decay, you do have to make sure that you're doing 1 minus that number. Now, pause the video and try C and D now. So for C, your initial value is 35. Your growth factor would be 0.75, which is a decay because it is less than 1. And to get the decay rate, 1 minus 0.75 is 0.25, and when you change it to a percent, you would get 25%. For D, your initial value would be 12. Your growth factor is the number inside of the parenthesis, which is 1.456. You know it's a growth because it's greater than 1. And your growth rate would be 45.6% because, again, subtract 1, you get 0.456, and move your decimal 2 to the right. Going on to the next page is where we're looking at the word problems. Every time you do a word problem, I want to see a few things as far as the work goes. You deposit $200 in the bank. That should be circled and labeled that that is your initial amount. So always make sure that you're labeling the word initial. Then I also want to see what formula you're using. If this says the word increase, 1 plus R, then you will write down 12% and show me that you move the decimal 2 to the right, therefore making your decimal 0.12. So your initial value is 200, your growth factor is 1.12, and then you would write your equation, y equals your initial amount, your growth factor goes on the inside, raised to the x power. Question number 2 is saying the population is 4,000. 4,000 is your initial amount, which I want labeled. Every month the population goes down. 1 minus R, 12%. You move the decimal 2 to the left to give you 0.12. So my initial value is 4,000. My growth factor is 1 minus 0.12, which gives you 0.88. And to write the actual equation, y equals your initial amount. Inside, you put your growth factor of 0.88 raised to either the x or the t power. You can use whatever letter you like. For number 3, the bank account has 5,000, which is your initial amount. This is talking about interest, which is 1 plus R. And my percent is 8%, where I'm going to go 2 to the left for 0.08. My initial amount is 500. The growth factor is 1 plus 0.08, which is 1.08. And my equation would be y equals my initial amount, parentheses, my growth factor is 1.08 raised to the x power. Going on to the next question, number 4, they want you to identify the initial value in each formula below. Pause the video and do that now. So keep in mind the initial amount or value is the number in the front. So for the first one, your initial would be 2. The second one is 2. And your last one would be 2/3. Now they want you to state whether or not it is a growth or a decay. The rule for the growth and decay is if B is a number greater than 1, it will be a growth. And if your B value, or the number inside of the parenthesis, is less than 1, then it would be a decay. Pause the video and do that now. Now the first one would be a decay because the number inside of the parenthesis is less than 1. 2/5 as a decimal would be 0.4. The second one would be a growth because 5/3 is greater than 1, and the last one would also be a growth because 3 is greater than 1. The multiple choice on the bottom, number 5 is asking you, what is the y-intercept? The y-intercept is the same thing as the initial value. So in this case, my initial value would be 5,000. So that would make it choice 3, 5,000 is the account initially. Going on to the next page for your word problem, the population of wolves is given by this equation. Now, before we even start the question, I always want you to realize what this is talking about. This means that there are initially 80 wolves, and this will be a decay because the number is less than 1. They want you to predict the number of wolves in 2008. That does not mean to plug 2008 in for time. It's starting in 1998, so what you need to do is subtract the numbers to get 10. They're talking about 10 years. That means to take and plug in for t, since that would be your time. So 80 parentheses 0.98 raised to the 10th power would give you 65.3658. Now you can't have a decimal amount of wolves, therefore you would have 65 wolves. Keeping in mind that since you realize it's a decay, if you started with 80 initially, then it would make sense to have 65 wolves 10 years later. Going on to the next question, which of the following statements is true? So before you even look at the choices, you should be labeling that the 12,000 is the initial amount. The 0.75 means that it's a decay because it's less than 1. And when you figure out the actual rate, 0.25, which becomes a 25% decrease. So now when you look at your choices, the correct one, it costs $9,000 when purchased. No. Choice 2, it costs $12,000 when purchased. That would mean the initial value, which would be correct. Be careful about choice 4, where it's decreasing at 0.25%, because it's actually 25%, not 0.25. So make sure you're careful with that. Going on to the next question, you're already given the formula, and just by looking at the formula, you can tell that $1,000 was the initial amount invested. It would be a decay because the number inside of the parenthesis is less than 1. The question is asking you how much would it be worth after 5 years? The 5 years then would be representing the time. So in order to do these questions, you would just want to take your time, which is 5, and plug it in for your exponent. You would type that entire thing into your calculator and get $168.07. Since it's money, you should have 2 decimal places for that. Now, number 9, 10, and 11 we'll get back to later on in the unit. Now for homework tonight, you're going to be doing IXL section X.5 for 20 minutes or until you get 85%. Have a good day. I'll talk to you tomorrow. Bye.